Objective 8, demonstrate an understanding of the concepts and uses of measurement and similarity. So here we have problem number 35. The figure below shows a CD in its rectangular storage case. Which is the closest to the area of the storage case not occupied by the CD? So here we have the CD case, and we have this place where the CD was, this white spot, and we want to know what's the area of the figure that doesn't include the place where the CD occupied, or in other words, this white spot. All of this white part we don't want to know. We want to do without that. So the way I suggest that these type of problems are approached usually approach these problems is, let's find the area of the big figure first. Let's look at the entire rectangle. So I have this rectangle that is a 14 by 12.4 centimeter rectangle. And remember that the area of a rectangle is equal to length times width. So the area of my rectangle here is going to be 14 times 12.4. And that gives me 173.6. So the area of the whole rectangle is 173.6. So what I want to do is I want to take that area and I want to subtract out the area of this big white circle. And remember that the area of a circle is equal to pi r squared. Now all this information is on your formula chart. So for my circle, my big circle, I have pi times r. Well, what's r? Well, this side of my rectangle is 12.4. So that means the diameter of my rectangle is also 12.4. Which then means that my radius from the center to the outer edge is half of that, which is going to be 6.2. So let's think about us having a big circle there with a radius of 6.2. So pi r 6.2 squared. Now I also need to consider this middle circle here, the small little circle here in the middle. Now I've found the area of the big part, and I'm about to find the area of my circle, my big circle with this. Now I'm going to subtract out that area of that big circle, but I need to add back in that area of that little circle there. So again, it's a small circle, and the area of a circle again is pi r squared. So I have pi times my radius, which in this case my diameter is 1.5. Remember, the diameter goes from the side to the side going through the center. So I need half of that, which in this case is going to be 0.75. So my r is 0.75. And I want to square that as well. So it looks like we have this number sentence. The area of the big rectangle minus the area of my big circle plus the area of my small circle. And let's see what that gives us. I don't have to necessarily calculate these two small areas out. If I want to leave these expressions like this, since pi is a key on my calculator, I can just put it in just like that, and my calculator will do it for me. So 173.6 minus parenthesis and I get 54.6, which is choice A. Number 22. A diagram of a power volume control knob on a stereo is shown below. When the stereo is turned on and the knob is turned to a volume level of 5, the knob is rotated 100 degrees from its off position. What is the approximate arc length of the path traveled by the knob's rotation from the off position to the volume of level 5? So here we are at off. We're going to rotate this knob 100 degrees to this volume level of 5. Now this mark right here, this is the arc length, the arc, and the length of that would be the arc length. So I need to find that distance, and on the tax test you're very likely going to have a problem like this, and there's really a formula that you need to know. It's something that you could come up with, but if you take the formula that I'm about to give you and commit it to memory for the test, then you won't have to come up with it on test day. And that formula is this: the angle that you're talking about, that angle in degrees, over 360 degrees, because there's 360 degrees in a circle, equals the arc length divided by the circumference of the circle. Let's put that into practice. So the angle that I'm talking about in degrees is 100. So I have 100 over 360 equals the arc length. I don't know that. I'm looking for that, so I'll call that x, over the circumference of the circle. Now, if you look on your formula chart, you'll see that circumference is either pi times diameter or 2 times pi times the radius. And that's one we'll use since we are given the radius. So if I fill in what I know, I'm just going to erase the r here and plug in what that is so I don't have to rewrite it. So the circumference of my circle is 2 times pi times 25, which is the radius. And I can solve for x by cross multiplying. 360 times x equals 100 times all of this, 2 pi times 25. And since I'm solving for x, what I'm going to do is I'm going to divide by 360. That goes away. Divide by 360. Now if I put all this in my calculator, it's going to give me the answer. Remember, when you put something in the calculator, always use parentheses. Now instead of brackets here, I'm just going to use another set of parentheses. That's fine. So open parenthesis. That's my entire top divided by 360. And I get x equals 43.6 which is J. Number 2. Triangle WXY is isosceles, which means that two sides are equal. It says segment or side WY is 10 centimeters long. Find the length of XZ. So we're looking for this length here, XZ. So we have several things going on here. I know that since this is an isosceles triangle, these two sides are the same. This side's also 13. I am given that WY, the base of the entire triangle, is 10. Now, what do I know about isosceles triangles? I know that, and I could use this information, that the base angles are congruent. So what I need to do is I need to figure out how can I find what XZ is. And I've kind of got a clue here. The clue is that I'm given a right triangle, two of them. This big triangle makes two right triangles. And what's one way that I can solve for missing side of a right triangle if I have two sides? And that would be the Pythagorean theorem. A squared plus b squared equals c squared. Now I know that the whole bottom here is 10, but I don't know this missing piece here. But I'm kind of guessing that this is going to be 5. And I can prove that that's 5 two ways. In geometry, we have a theorem called the hypotenuse leg, which means if you have the hypotenuse of one triangle is congruent to the hypotenuse of another triangle, then and a leg of the other triangle is congruent to another leg of the triangle, then the other two legs are also congruent. For example, I know that these two triangles, this yellow highlighted one and the blue highlighted one, they're two right triangles and their hypotenuses are the same. So far, I'm good with the hypotenuses. They're the same. This one's 13 and this one's 13. Now let's look at the legs. I have two legs. I've got this leg that they share, and I have these two legs over here. Right now, I don't know anything about these two legs, but I do know something about this leg. If I took those two triangles and split them up, these would still be 13, my hypotenuses, and these sides would be the same by the reflexive property because they're the same piece. So then I have a leg of each triangle that are congruent to each other. So that tells me that these two legs are also congruent. That's the hypotenuse leg theorem. And since they're congruent and the total of the two is 10, that means each one is 5. That's one way you can determine those two missing pieces. Another way you could determine those two missing pieces is since our base angles are congruent here and here, and this is 90 degrees here and here, then I could use angle, angle, side. Angle, angle, side. Angle, angle, side theorem to prove the two triangles congruent. And if the two triangles are congruent, then its corresponding parts, this side and this side, are also congruent. Now that was a lot of explanation about how to figure out what these two missing legs are, when pretty much you could probably just look at it, which I usually tell for geometry, never go by what something looks like. But in this case, they've got to be 5. And those are the two ways you can prove it. So I'm going to use Pythagorean theorem to find this missing piece. I'm going to call this A, and I'll call my missing piece B. So I've got 5 squared plus b squared equals 13 squared. Simplify. 25 plus b squared equals 169. Continuing to solve for b, subtract 25 from each side. I get b squared is equal to 144. Take the square root to find out what b is, and I get that b is equal to 12, which is letter H.